Oh, this is impossible. No. Now wait just a second. Yes, indeed, this is quite the word problem here with this nice, large, and intimidating graph taken exactly from the 2016 AP Calculus test. That's right. This was indeed one of the problems that I went over on our live stream earlier this week. But without a doubt, this is something that, with a few tweaks to it, can definitely be geared towards what we were trying to talk about earlier with some definite integrals. So let's have a quick look at this and we'll see how we can solve the problems that they are asking for. So to begin with, we have this entire graph here going from -4 on the x value, and as this thing crawls up and down, it ends at a +12 on the x. Okay, something to note here, of course, is that this is the graph of f only. This is one function, we will call it f. They give us another point here as well, that we have another function g, which is defined as the definite integral starting from 2 all the way to x of f of t dt. Okay, and so with that, g is related to x in the form of an integral, and so our first problem, part A, reads as such. They are asking us if g has a relative minimum or maximum at x is equal to 6. All right, so that's quite a bit going on over there, but it should definitely be something that we are able to start deciphering and finding some solutions for with all of the knowledge of calculus that we know beforehand. So let's have a look here first, is that they are looking for a relative minimum or maximum, again, for the function g. What does that mean, of course, is that if we want to know relative minimum or maximum for any sort of function, in this case, even if they're asking for the function of g, all we need to do is look at its first derivative, and then we do a little bit of something called, what we like to say, a number line analysis here, right? So again, if we would take this function and put it onto a number line, all that we're looking for is at that targeted value of 6 on the x, do we have a change from a positive to negative sign on the function, or a negative to positive? And we are simply looking at the sign in front of the function as we travel across that value of 6. Again, because if we are going to posit to negative, that will be a function that is increasing to decreasing, and that is going to be, in this case, a maximum. Because the function was starting to increase, it hits that value and then it instantly switches to a decrease. That is known as a maximum mathematically. And in the inverse sense, if we have a function that looks like this, and then of course we are decreasing at the start, we hit the point in which we were inspecting, and then it starts increasing right afterwards, that is mathematically going to be a minimum. Okay, so with that all cleared up, what will the situation look at this problem here? Well, the first derivative of g, back to what we were talking about, is that we need to draw upon that relationship there, right? So the first derivative of g in this case is going to be the derivative in respect to x for that entire integral ranging from 2 all the way to x of f of t dt, just like that. Okay, now something to note, of course, is that, well, if we have a derivative of an integral, that brings us all the way back to the fundamental theorem of calculus, again abbreviated as FTC for us. Again, because if we're taking a direct derivative of a definite integral, what really will happen is that, again, only from these two limits, only the one with the variable will remain, because of the fact that the lower limit, which is just a number, will give us a numerical value after we take the definite integral. So because of that, from the fundamental theorem of calculus, we can then deduce that we are just simply dealing with the function f of x directly as the first derivative of g. Very simple and very easy for us to then determine what we're looking at x is equal to 6. Okay, so instead here we need to look at f of 6 as a result, and thankfully we have the graph all the way for us right here. And so with the function of f, at x is equal to 6, it is indeed equal to 0. So that's the first step. That's nice, because 0 being that number right between all the positives and negatives, we can then see what the trend looks like on either side. Again, that is our number line analysis that I like to say. So in our case, because we have 6 as our point of analysis here, what are we looking at? As you can see, with the function of f now being our target right now, we are going from an increase down to a decrease. Okay, again, or in this case, what I like to say instead, because that's from the case for g, we are looking for a positive sign into a negative sign. Again, just the sign on the f is what matters. So again, the function of f was positives leading up to 6, and then negatives afterwards. Again, this is for the first derivative of g, which means that g was increasing first and then decreasing afterwards. Mathematically, for part A, that is going to be a relative maximum at x equal to 6. Okay? And so because of that, we can leave that as a note here on the side, right? So g of 6 is a relative maximum. All right? So because of that, this is going to be our definitive answer for part A. And so now we will need to move on to part B. We kind of cluttered this because there isn't very much space on this blackboard, but with a nice easy clearing like this, we can then go and see what part B is now asking for. So as our ability to read through this, it says here on part B that we need to find the absolute minimum and maximum of g of x from the interval -4 all the way to 12. Okay, so because of this, there's a little bit of a difference. Part A was asking for relative, while part B is asking for absolute. There is quite the difference there. Okay, so with absolute, again, we want minimum and maximum, so we need to look at all of our available points and then come up with a conclusion after comparing all of them. So what I like to personally say for myself when I try to solve this problem is that we need to look at candidates. Okay, there are some possible points for us that will be part of our selection process here. And so with our candidates, at least for absolutes, we need to look at the following. Okay, first we need to look at relative, minimums and maximums. Right, that should be going without saying because of the fact that it's a min or max for that area, so we must compare it to the rest of the points that may or may not match or beat out that result. But then, because they're asking for absolutes, we also need to look at the endpoints. That is another set of points in which we need to look at for ourselves so that we can conclude, again, did we start at a very low end or did we end at a very high note? Again, that really does depend on what the function looks like, and we need to match that accordingly from the problem. Okay, and because of that, we have a few candidates, right? We already confirmed that 6 on the x was a relative maximum, but also, if that's the same case, anything that crosses that x-axis will then mean that -2 would also be a possible candidate because it crosses from the negative side into the positive side, making it a relative minimum. Okay, so for our relative points, we have the x is equal to, in this case, -2, and we have it also equal to +6. And again, the endpoints, which will mean it's -4 and +12. We need to check those as well. So -4 and +12. These are the 4 candidates that we will choose on the side of x, and therefore we need to then look at what it looks like for the function g this time. Okay, and again, how then will we find each point according to g? Well, that just means we need to refer back to that first part right there, that g of x is equal to the integral defined from 2 to x of f of t dt, and then we can start determining what each of them will match up inside of this table. So let's get started first with, in this case, from the very top here, the lowest number being x of -4. So Then we can start over here at this time. So again, g of -4 in this case. Now let's go ahead and define that based off of the integral. So it goes from 2 to -4 of f of t dt. Now, we don't like this actually because the limits are not where they should be. This from going from 2 to -4 is a little bit odd. So instead, we want to change our limits going from the low point to the high point. So that's going to be negative instead, -4 on the bottom, 2 on the top, f of t dt. Some very standard limit manipulation for this type of problem. And so how do we do this then? Right, we're going from -4 to a +2 on the function. Well, in this case, because we're taking the integral of f, which was this graph in the first place, we just need to look at the area underneath the curve. And so, because of that, we have, as you can see, this a section of negative area, and then all of this a section of positive area, as can be seen right there. And they're both triangles, so that should be pretty easy for us to then determine the areas. Going from -2 to -4, that is, to +2, we have a triangle with a height of 4, -4 that is, and a base of +2. Height of -4, base of +2, well, that means we just end up with an area, and keep that negative as a coefficient, and that's a -8, we divide it by 2 because it's a triangle, so that's a -4 area to begin with. And then we add that now with a positive triangle here. Looks like we have a base going across of 4 units and a height going up of +4 units as well. So that will be a total area of 16 divided by 2, making it a +8 to be added along with that. Remember to keep track of that negative coefficient. And so g of -4 will then give us the result of another -4, +4 inside, negative coefficient slaps on that negative sign on top, and so we get -4, -4 as a result of that first point. Okay, moving on here, then we have to look at g of -2 instead, okay, which will then mean it goes from +2 to -2, the f of t dt. Okay, so this guy though, this same idea that we start at a +2 ending at a -2, we want to flip that because we want to start low and end high. So in this case, by flipping, going from -2 to +2 for f of t dt will look like that. Okay. Now, thankfully though, from -2 to +2, we already solved for that area. That was an area of +8 to begin with. So that's just one single triangle. There's no need to add multiple sections. So this ends up as a -8 as a result of that point right there. Then we can go to the next point. We have 2 more to go. We have g of +6, and that'll be defined going from 2 to 6, f of t dt. Now, thankfully for this guy does not need any sort of change at all because going from 2 to 6 is exactly the order that we want to. So let's just have a look at what that looks like on our end. Going from 2 to 6, again, that is a base of still 4, another section of triangle, and the height of 4 again. So that's just another, this time, a +8 result of an area for that triangle. So we'll record that down. And lastly, we have one more to go, which is going to be g of +12. And this goes from 2 to +12 of f of t dt. Okay, so lastly, we need to start from +2 and ending at -12. Okay, something to note now is that we have this section of negative area we need to keep track of that's underneath the x-axis. And so the same idea, we have still here a base of 4, and now this time a height of -4 waiting for us. And would you look at that? That is completely the inverse of the first triangle, now with just a negative height. And so those will both cancel out to a 0 for now. That makes our life so much easier. But we're not done. We still have this last segment right here. Now this time coming across as a base of 2 and then a height of -4, which was very similar to the first triangle that we dealt with, which ends up with a area of now a -4 for that triangle. Okay, so g of +12 looks like ends up as -4 in comparison. And would you look at that? we do have things that are labeled out for us as 6, 8 is the highest positive point for G, right, with a positive 8, and then -2, -8 would be the lowest point for that. Okay, so we can note this down and we should be well on our way out of here. So the absolute minimum, right, is going to be at G of this case, right, the smallest number of -2, which is equal to -8, and then the absolute maximum this time is going to be G of, in this case, +6, which results in a +8 for that function. And there you go. And that is indeed how you solve for this kind of problem. Again, something that the graph itself was on a previous AP exam. So this level of being able to decipher and make out the areas for these sections underneath the curve using definite integrals is exactly something that they will ask on the test. So hopefully with this all recorded out with each of the steps, this should be helpful for many of the students that are going through this part in their practices ready for the exam. So with that, this really does conclude the last section that I have for definite integrals using the fundamental theorem of calculus. But the next section though will indeed be a very visual one, because the next one that I envision seeing is going to be one that deals with areas between multiple curves, as well as any sort of rotational and three-dimensional volumes that come from that. That one is indeed quite the daunting task, but I think with all that we have learned so far, it should definitely be a lot easier to get through that section. So we'll see how you all keep practicing. Again, I'm streaming twice a week on Tuesdays and Thursdays, where any sort of questions could be answered, and we hope to see you there.